All right, boys and girls, welcome back to the drive-thru. Sponsored as always by the deli. Hungry? Stop by the deli. Make yourself a mayonnaise sandwich on Wonder Bread. Officially the cheapest sandwich you could possibly make. So, we are into 2.7 today, the transitive and the substitution properties. Each day, we are getting closer to doing real geometry. So, transitive property is like one of the biggest ones. Just remember, transitive doesn't work in sports. So just because you beat Team B and Team B beat the champions, that doesn't mean that you're better than the champions. People misuse that all the time in sports. But it does work in geometry. So transitive just says if angles are congruent to the same angle, then they are congruent to each other. So all right, so if I knew that segment AB was congruent to XY, and I also knew that segment XY was congruent to GU, transitive allows me to skip the middleman. It's kind of like the chain rule when it comes to logic, and it allows me to say that AB is congruent to GU, okay? That's what Theorem 16 is telling us. Now watch how closely Theorem 17 resembles that. We just call that the Transitive Theorem, by the way. If angles or segments are congruent to congruent angles or segments. So, if I know that angle 1 is congruent to angle 2, and I know that angle X is congruent to angle Y, and I know that angle 2 is congruent to angle Y, if two angles, okay, are congruent to the same angle or to congruent angles, so I can deduce that angle 1 is congruent to angle X. Okay, that's kind of like a transitive law involving two middlemen. It's the same thing. You'll get good at that. Okay? So both those we'll just refer to as the transitive theorem in this class. All right, now the substitution theorem, you know, a lot of times people get it confused with transitive. Sometimes we can use either one. So the substitution property is used in our proofs, and it will often be beneficial to use so that we can substitute things into sentences. So I'll just read this. If angle 1 is congruent to angle 2, and angle 3 is complementary to angle 2. Now this is a sentence. Sorry, angle 2 is complementary to angle 3. That is a mathematical sentence, okay? If we substitute angle 1 in here for angle 2, due to the fact that they are congruent, then we could not use transitive, because transitive only is involved with congruence or equality. If we put something into a statement or a sentence, that is substitution. And that's virtually what I explained right there. So if you're confused, you might want to pause it or rewind it. Okay, we're going to do two examples on this. So we are given that FG is congruent to KJ. Okay, we'll just go with that. And we know that GH is congruent to KJ. All right, well notice, this sets up perfectly right here. We got two things that are congruent to the same thing. So first, let's list our given. FG congruent to KJ, and GH is congruent to KJ. Hopefully you know what the next step will be. we will instantly say that those two are congruent. FG is congruent to GH. My reason will be transitive. Okay. Well, now that I know FG is congruent to GH, I can say that KG bisects FH by the definition of bisect. So there you'll see how we'll use transitive in a proof. Okay? And finally, one more quick little proof involving substitution. So we are given that angle 1 plus angle 2 is equal to 90. And angle 1 is congruent to angle 3. Okay? What I'm going to do is take out my angle 1 and substitute angle 3 in for it. So I can say that angle 3, plus angle 2 equals 90, and my reason is substitution. Boom!